In this last example, we're going to look at the average value of a multivariable function. So the definition is given here. The average value, f bar, of the function in the domain given by the region t is defined to be 1 over the volume of the region times the triple integral of the function over that region. Now let's just think about why this would be the case. So when we're thinking about the average value of a function, we're trying to think of if I could replace the function with a constant function, what property would that constant have to have? So what we would want is we want a constant, in this case we're calling the constant f bar, such that we want this constant to have the property that if we integrate it over the whole region t, so integrate f bar over that whole region t, that we get the same value as if we were to integrate the function itself, f of x, y, z, over the whole region t. So that's what this constant is supposed to have as a property, that integrating our function over the whole region would be the same as integrating this constant over the whole region. That would be the average value. And then we just notice that since this is a constant, it could come out of the integral, and we're just left with f bar times the integral over t of the function 1 dv, and that's just volume. So it's f times volume is equal to the triple integral of t f of x, y, z dv. And that's precisely what that equation says, that f bar is 1 over the volume times the triple integral of the function. So let's have a look at an example. We're going to find the average squared distance from the origin of the points of the pyramid bounded by the plane and the 3 coordinate axes. So if you notice, this is the same plane we had from the first example of this section. So we've got this plane 6, 3, 2, and it cuts out this tetrahedron in the first octant, and we are interested in the average squared distance from the origin to the points of this tetrahedron, of this pyramid. And so what we'll note here is that this is given by z is equal to 6 minus 2x minus 3y. We already found out that the volume of this region is given by 6. This was as computed in first example of this section. And so now let's work out the average value of this particular function we're interested in. So what is the function? F of x, y, z is equal to the average squared distance. So our function is x squared plus y squared plus z squared. So that's the one we're trying to find the average value of. So that's f bar. We compute it by 1 over the volume of the region we're interested in, and then we integrate over that region. Now we've already set up the integral for this region when we computed the volume, so we'll just use that integral. So that was the integral from 0 to 3, from 0 to 2 minus 2/3 x, and then from 0 to 6 minus 2x minus 3y. And the function we're integrating is x squared plus y squared plus z squared dz dy dx. So we already set up this integral from before. The only subtle difference is originally we set it up as a double integral to compute the volume, but then I said, well, this is how we can interpret it as a triple integral, and that's the interpretation we needed here, because we need to integrate over all points over the entire solid of this function x squared plus y squared plus z squared. So then we can go ahead and say, well, what is our volume? Our volume is 6, so we're taking 1/6 of the integral from 0 to 3, the integral from 0 to 2 minus 2/3 x, the integral from 0 to 6 minus 2x minus 3y, x squared plus y squared plus z squared, dz, dy, dx. So there is our integral representing our average value. We can go ahead and compute this, and what we end up getting is the value of 49 tenths, or in other words, 4.9. So that is the average square of the distance from a point in this tetrahedron, in this pyramid, to the origin. Alright, that's it for this example. Thanks for watching, and we'll see you again next time.